Good morning, afternoon, or evening, everybody. My name is Wyatt Devine. I'll be discussing the environmental cost of the Gulf War. I conducted my research here primarily using U.S. and other official sources to provide estimations of emissions or provide a baseline for my own calculations to derive emissions from our numbers in official sources. Seen here are the 6 main topics I'm going to discuss. First is a quick explanation of how an Army uses energy and why military operations have such a large potential for pollution and affecting the world's climate. Second, we'll discuss the impacts of ground fuel usage and why usage can be so high. Third will be emissions from the air campaign. Fourth will be potential emissions from ammunition usage, such as rifle rounds, bombs, or artillery shells. Fifth, we will discuss the Kuwaiti oil well fires. And sixth, we will touch slightly on a issue that is in the realm of climate change, but generally would affect cleanup efforts more during recovery from a climate change event, which is depleted uranium. To understand the numbers we're going to see in the following slides, we're going to need to put an Army's energy use into perspective. A military uses energy to fulfill 3 main functions. Equipment, manpower, and logistics all require energy expenditure and thusly pollute when they use that energy. Nearly every piece of military equipment in the U.S. Army, Navy, Marine Corps, and Air Force uses jet fuel, which we will use for our calculations. During the Gulf War, it was a transition period where we were using DF2 and JP8, which is diesel fuel 2 and jet propulsion 8, and we were using jet propulsion 7 at that time. But I used the standard jet fuel calculations from the EPA's website to ensure that my numbers were consistent on one baseline. One fact of note to mention before moving forward is that the US DoD uses about half of all federal energy usage per year, which is a massive chunk considering the different federal agencies that operate in the United States. We'll start out by examining the pollution from ground fuel and why it can be so high. Military vehicles generally have a low efficiency, with heavy equipment trucks of 25 tons getting about 2 miles per gallon, which is quite poor compared to what many are used to. There was a lot of waiting around for the ground phase to begin, so that means troops were building up areas using generators, burning fuel while waiting for the war. The large tonnage that moved through the desert at a rapid pace had to use a lot of fuel. They needed to move quickly and try to get to Baghdad as fast as possible, so they were not concerned with fuel usage. Atkinson estimates that we used about 15 million gallons per day during the ground phase. Draw that line out for 100 hours of ground combat, about 4 days, and then we burned 60 million gallons in 4 days. One personal example I have of the high fuel usage that can come from a single piece of equipment is from my deployment in 2017. This is a generator truck called the EPP, the electric power plant. Both generators have a 100-gallon fuel tank that provides for 24 hours of operation. Just running the radar and engagement van, we burned about 200 gallons per day if we were up for 24 hours. Multiply that by 200 days of equipment uptime during our 9-month deployment, and we burned about 40,000 gallons of fuel for one unit, and that's not including launchers or other auxiliary power. The airfares of the Gulf War actually made up the bulk of the offensive operations during the war. About 100,000 missions were flown by the coalition during hostilities by a variety of aircraft. From targeting and imaging aircraft, refueling tankers, airborne early warning, and conventional bombers, there was a multitude of aircraft used. The big problem that comes from using jet fuel in the air is it contributes particulates and pollutants directly into the atmosphere. The EESI lists these pollutants as CO2, nitrous gases, water vapor, soot, sulfates, and other particulate matter. Here are my calculations for the total fuel use emissions. I took the 2 billion gallon figure listed by Thomas in his study of petroleum use in the Gulf War. I multiplied that by the conversion from gallons to kilograms, 3.04, which yields 6.08 billion kilograms. 6 billion kilograms of fuel multiplied by 3.16 kilograms of CO2 per kilogram burned of jet fuel equals 19.2128 billion kilograms of CO2 from fuel use alone in the Gulf War. Next, we'll cover ammunition. I chose to examine ammunition use because ammunition can contribute many different pollutants to the environment. The largest one I will focus on is CO2, because that will keep the numbers consistent when we go to our data analysis. It also contributes carbon monoxide, lead, methane, nitrous oxide, and PM 2.5 or PM 10, which the EPA has classified as a class of particles that can be harmful to humans and the environment. It is notable that exhaust particles and fire smoke can also contribute to PM 2.5 and PM 10. Considerations for my ammunition calculations are as follows. The emissions are different by caliber, and currently there was no small arms data available. Only U.S. emissions are going to be estimated, and this is only for 7th Corps and 18th Army Corps only. This is provided by Crawford's ammunition study from 2019 for the U.S. Army War College. Currently, the EPA does not list emissions figures for unguided, guided bombs, or precision-guided missiles, so I cannot analyze the air campaign. I took the amount listed in Crawford's study and then cross-referenced that with the EPA's numbers of emissions per firing. As you can see, the M1 Abrams 120mm gun is an extremely dirty weapon as far as CO2 goes, with 14 pounds of CO2 being emitted per firing of that weapon. One of the most notorious images from the Gulf War are the great black plumes of smoke from the oil field fires in Kuwait. The Iraqi military had set these oil fields ablaze in order to slow coalition advances and to burn away some of Kuwait's oil supply. These wells burned for months until the coalition pushed Iraq out and the area was safe for firefighters to beat back the blaze. The emission of pollutants was significant enough to cause sand that many called, according to NASA, tarcrete. The fires burned long enough to reduce Kuwait's oil reserves by about 2%. The end result was about 1 billion barrels of crude oil burning during that conflict. This was so severe that the EPA and other national and international agencies immediately began writing articles describing this as an international crisis for the environment. Additionally, many millions of gallons of oil were released into the ocean, causing harm to sea life and those ecosystems. My final touch point is going to be the use of depleted uranium in the Gulf and how it can affect future cleanup efforts due to environmental change. It complicates issues in affected areas where depleted uranium ammunition was used. Depleted uranium is used to enhance target penetration of fin-discarding sabot rounds, which are tank rounds that are shaped like a dart. They're meant to pierce through armor, not explode through it. This can cause problems for soldiers, civilians, or animals due to the radioactive nature of depleted uranium. Working around DU exposure could slow future efforts or worse, even harm those trying to dedicate their time to cleaning up the area. It is estimated that we used about 315 tons of depleted uranium rounds in the Gulf War. This is enough of a health issue that even today, post-deployment health assessments ask you if you're around depleted uranium rounds. I created the top table to compile the numbers from our previous calculations. Fuel has contributed an estimated 19 million tons of CO2. Ammunition was just 92 tons, considering that we did not have bomb or missile data. And oil fires contributed about 118 million tons of CO2 due to the dirty nature of crude oil and the exorbitant amounts that were burned. Overall, this comes out to 0.137 gigatons of CO2 emitted during this conflict. Compared to the 2018 emissions from the Union of Concerned Scientists, this means that the 1991 Gulf War at the very low end contributed about 2.5% of what would have been our national CO2 emissions. Overall, before I conducted my research, I expected the emissions from this conflict to be about 10% of the US's emissions by comparison. I was surprised by the small amount of CO2 generated by some ammunition use. Additionally, I was surprised by the massive portion of emissions that the Kuwaiti oil fires made. The damage from the fires seems to be hard to overestimate. I'd like to close by thanking you for watching, and please comment below if you have any questions. Thank you again.